Right, chaps, good morning, morning. Mr. Lesham is here. We are still in quadratic equations. And what we're going to do now, this is going to be a bit of a long lesson. We might break it into a few, we'll see. We've worked with this form of this quadratic equation. Y equal x plus p squared plus q, that should be p. And this form is very useful in allowing us to find the vertical shift, the horizontal shift, and the flapping shift, we'll call it, I don't know, okay. That's a bit more difficult to find. But there are other forms, other ways, when I say other forms, I mean other ways of writing quadratic equations or quadratic function. The first one we came across, okay, what is the first one you came across? Okay? ax squared plus bx plus c. So that's the first way you came when you were introduced to quadratic expressions. Okay? So what we're going to do now, we're going to look at functions that are drawn in this way and then try and maybe sketch them or get some information about them. Okay? So far all the quadratic forms I showed you were like this and maybe we had to sketch them. But what happens if you were giving it in this way? Okay? So more specifically, we've given this quadratic function, y equal x squared minus 4x plus 3. And we want to find the TP. What does TP stands for? The turning point. Now, we've not asked to do that, but I think it's useful just to try and, in our minds, sketch it. It's not going to be a correct sketch, but it's just to give us an idea. Is this a smiley face or a sad face? Smiley. Whatever is in front of the x squared, that tells you if it's a smiley or sad. So I don't know, let's just say, for the sake of it, that it's something like that. Okay? By the way, I can know straight away what that number is. Because when x is 0, the y-intercept is this. And this is one of the great things about this form. This form gives me the y-intercept very easily. If I put x is 0 here and here, that's your y-intercept. Where we didn't really have it here. It wasn't that easy to read what the y-intercept is. So every form has an advantage. More on that later. That's not why I'm interested. Why I'm interested is to find the turning point here. Turning point. So how are we going to do that? Let's pause and see if you've got something to say. Okay, right, we got an answer from you. Okay, so we've done that earlier in the year. Okay, where I gave you something like this: x squared minus 4x plus 3, and I'll ask you what is the minimum value of this expression. Okay, and what we learned to do is that we need to complete the square. Okay, so I'll remind you how to do that. Okay. To complete the square, it only, first of all, if you have, you can go straight away only if you have a 1 here. If you don't have a 1 here, maybe we'll look at another example later, it's fine, you just have to factorize it first. But when that's the case, you do x, it will be x minus something squared. What is this something? What do I do here? Divide by 4 by 2. I look at the number in front of the x and I divide it by 2. Okay, so I'm going to write a 4 divided by 2, even though you know straight away it's 2. But just to remind you, okay? So we divide this by 2, we put it there, and now we need to minus the square of this term, the square of it, kill it. Okay, you can listen to another video that I did before to remind you why we're doing that, but now I just remind you. And then we need to add plus the 3. That's how we find it. Okay? So I'll give you a general way of doing it in a second. But so basically you've got y, in this case, y x minus 2 squared. This is minus, this is 2. 2 squared is minus 4 plus 3. In other words, y equal x minus 2 squared minus 1. Okay? I'll just pause. Alright, so I can see quite a bit of confusion here. As I told just now, we're going to see a trick that will make it a little bit easier, but you still need to know how to complete the square. So I will use this opportunity to remind you how to complete the square. If you have a certain quadratic expression that looks like this, x squared, let's use different letters so you're not going to get confused. dx plus e. Okay? If you want to complete the square, what you got to do is, you got to write down x plus, you take the number in front of the x, you halve it, b over 2 square. Okay, that's your first part. Then you do minus this same term divided by 2 square. This is just a way of we learn how to do that. Okay, it's just something you have to remember. Completing the square. It ain't that easy, I know. Okay, and then plus e. That's how we wrote it. Okay, so I use this for d equal 4. Okay, all right. Now, what we end up is this. From this, we should be. We don't need to factorize. We can, if we wanted to know something else, we'd factorize. But from here, we can find out what's the turning point. Okay, because the turning point is basically when this thing is 0. This is how we've done it. When is the minimum? When this is 0. Why? This number that is squared, is that positive or negative? Positive. It's always positive. So this thing here is always positive. There's one value for x where this is not positive. It ain't going to be negative because it can't be negative, but it can still be 0, right? When is this going to be 0? When x is 2. Okay? When x is equal to, what is y going to be? Well, 2 minus 2 squared is 0. It will be minus 1. Minus 1, yeah? Because I've got minus 1. Yeah? Okay? So what's my turning point? What is the turning point? 2 minus 1. That's my turning point. Okay? So I'll repeat again. I'll repeat. What did we have to do? Okay? We took this 4. Don't worry. I know it's difficult and I'm going to show you a much easier way of doing it in a minute. But I still need to show you where it's coming from. So if we were given this form straight away, it would have been easy to find the turning point. It's basically when x equal minus 1. Okay? But now, if we were given that, so we have to do a little work here, and we have to transform that into that. Now, I didn't say it, but I'm just going to say it now. This is exactly this form. So what we've done by completing the square, we went from this form to that form. And this form is good at telling us what's the turning point. The turning point is always the x, which makes this 0. So it's x equal 2, and then when this is 0, y end up being minus 1. Okay? I'll pause here for a minute. Now, when I got you to work so hard, let me get my pen. Okay? When I get you to work so hard, I'm going to show you how you can do it in a much, much easier way. Okay? Right, so I'm going to rewrite it again. I've got y equal x squared minus 4x plus 3. I'm asking, what is the turning point? Okay? Alright? Well, a turning point is a coordinate, so I'm looking for x and y. Right? I found the answer, but I'm going to show you how I can do it much, much easier way. What I can say is that in the turning point, the x, maybe let me write it down here. Okay? The turning point, let me write it down like this. Turning point of y equal ax squared plus bx plus c. If I give you a certain, doesn't cover that. If I give you a certain function, a certain quadratic function in this form, and you ask what's the turning point, the x is always going to be, drum roll,
minus b over 2a.
Fantastic. Always going to be minus b over 2a. Okay? Let's see how that works. Okay? Let's find what the x is going to be minus. What is minus b? What is b? B is 4 or minus 4. Yeah? B is minus 4. So minus b is going to be minus 4, right? Divided by 2a. What is a?
2.
2 times 1. So what I have, minus 4, 4 divided by 2 equal to 2. Voila! We got it. X is equal to 2. Correct. So the question was, how do I know what the y is? I've got the x, but I want to know the y. Easy, just substitute. Where substitute? Here. So we're going to substitute here. 2 squared minus 4 times 2 plus 3. We get 4 minus 8 minus 4 plus 3, you get minus 1. So again, the answer is 2 minus 1. The same as here, but much, 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 much easier, isn't it? Okay? The reason I showed you why this thing is, that's a good reason, good question. I don't know why I showed you, but no, it's something that you probably need to vaguely understand. But it's not something I'm expecting you to do in a test. In a test, you gotta use this. So highlight it, okay? The turning point of y, this quadratic form, is always, 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 I'm gonna highlight that in red. Where's my red? Okay? X minus b over 2a. And the y, I'm not going to write the y, you just substitute. Okay, let's pause here. Alright, chaps, so we're moving on, and this is going to be probably our last example in this, this lesson. We get another curve. Okay, deliberately I use f of x. We sometimes use f of x, sometimes y. Okay, and they're asking us to sketch the graph. Okay, obviously it's a parabola. How do I know it's a parabola?
It's square.
It's a square. Okay. Now, when I try and sketch a graph, okay, you can also probably tell me is it going to be a smiley face or a sad face? There will be a smiley face. Okay. Now, another thing you guys can tell me straight away. What's the y-intercept? -9. So I'm going to draw one thing, and I might be completely wrong, but let's just do that. Let's say it's something like this. We might have to change it later. Okay? Why am I drawing it like this? First of all, the y-intercept is 0 minus 9. That's definite, yeah? Okay? It's you said smiley face, okay? But it could be wrong, because actually it could be more like this. Yeah? There's a couple of ways. So I'm just drawing it because I personally like to have something in my mind. Okay? Now, we need 3 more bits of data to qualify for this, to finish this sketch. What else do I need to find?
Turning point.
The turning point. I must always find the turning point. And now I know how to do it. Am I going to complete the square? Most definitely not. I'm going to use the rule that we just came up with. So for the turning point, okay, what is x equal to? Minus b over 2a, so it's going to be minus 6 over
2 times 3.
2 times 3, which is
6.
How much is that? Minus 1. Negative 1. And then I want to know what the y is. So I'm going to put, how do I know what the y for the turning point?
Substitute x with minus.
Okay, so 3 times minus 1 squared plus 6 times minus 1 minus 9. Is that minus there?
Yes.
Yeah. Okay? Okay? Right, that is going to be 3 minus 6 minus 9. So that's going to be minus 12, I think. Just check me, please. Yeah.
No, that's minus 3, minus 6, minus 9. Not 3, minus 6, minus 9.
No, because Simon, this is square.
Oh, the square.
Yeah? Square. Okay? Okay. So I got lucky. I could have been wrong as well, but luckily this drawing is actually quite good. How do I know that? Because when x is equal minus 1, y is minus 12. So it is like this, and not the. In other words, the turning point is on the left side, not on the right side. I could have drawn it like this, and then I would have been wrong. Luckily, I was just lucky. Okay. All right. So we got the turning point. We got the y-intercept. What else do I need?
The coordinates.
The x-intercept. Okay, the x-intercept. How do I find the x-intercepts?
Substitute it.
Yes, Jacques.
You write the starting formula out, then you try to split it, and then you just solve.
Yes, I'm just missing the first bit. Okay, Buzwa, what happens to y? What is y equal in the x-intercept?
6 and minus 6.
What is the y here of these 2 points? That's the x-intercept. What is the y equal here?
Minus 9. 0.
It's 0. Okay, the y is a 0. So Jacques, what you're telling me really is that I should write 3x squared plus 6x minus 9. I don't know what the x is,
Divide it all by 3. Yeah.
but that's equal to 3. Wait, is that equal to 0? That's why I was missing.
Divide that all by 3.
Okay? But it's important you understand it, okay? The y is 0. Okay? Now, how do we solve it? Yes, divided by 3, or take a 3 as a common factor. So
why
we
divide by 3?
Well, I want to solve that. One option, I can only always use the formula. But we use the formula only for difficult ones. First of all, we want to see if we can factorize it. And that's a trinomial, but it's a difficult trinomial because it doesn't start with just x squared. But in this case, it's actually dead easy because I can divide by 3 to get rid of this. And 3 is a common factor. Right? So it's going to be x squared plus 2x minus 3 equal to 0. Are you happy with that?
Yes.
And that can be factorized easily. That's the first type of factorization you learn. What is it?
3 and 2 and 1. 2 and 1.
Forgot. If I do negative 2 and negative 1, when I multiply them, they must be equal to minus 1.
I thought it was when they add them.
When you multiply them, you get minus 3. When you add them, you get 2.
Plus 3
Plus 3 minus 1.
Good. Plus 3 minus 1, right? When I multiply those two numbers, it must be equal to that 3 number. When I'm adding them, it needs to be equal to the number next to it. Okay? Now this business, this is not, don't just let it hanging in there. I often see you guys writing a test that's not, I had an equation here. What happened to the equation? Okay? That still needs to be equal to 0. And that has two solutions. What are the two solutions? X equal minus 3 and x equal 1. And these are the two solutions, right? So I've got minus 3, 0 and 1, 0. And now we're done. Okay? So, right, I'll pause here and then I've got one more thing to say, but I'll do it in the next video. So, I hope you had fun. Let's do some work. Bye-bye.